Okay, in this video I want to show you how to answer the question in this practice question. Okay, so you already have your reading, right? So this is my reading, okay, this is my reading. So I purposely adjust the rheostat so that I can get the ammeter reading to be 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5 lah, so that I can plot the graph easier lah. Okay, this is how I carry out the experiment so that I can plot the graph much more easier lah. Okay, but the last one I cannot get 0.6 lah because already reached the maximum. Okay, so this is the corresponding voltmeter reading that I get. So make sure that when you plot, when you tabulate your data, make sure that all the decimal place is the same. And based on the number, the decimal place must follow the decimal place of the scale in the measuring instrument. Okay, in the measuring instrument. So in this ammeter, you can measure until 0.02 ampere. Okay, you can measure smallest to 0.02 ampere. So your reading must be 2 decimal place lah. Okay, so 0.10, 0.20, and so on. Okay. Remember, all the decimal place must be the same. In the same column, all must be the same. Okay, this is the voltmeter reading. So of course, the same thing. The decimal place must follow the measuring instrument. That means it must follow the voltmeter. So this voltmeter that we use, you can measure smallest is 0.1 volt. Okay. All right. So after that, follow based on the data, you plot the graph. Okay, plot the graph. So this is the graph that I plot. Okay, so there are a few things you need to pay attention when you plot the graph. First is the scale must always start from 0. The scale must start from 0. So for example, you see the x-axis 0, 0.1, 0.2, 0.3, 0.4, 0.5, and 0.6. Start from 0. And then this one 0, 0.2, 0.4, 0.6, 0.8, and so on. You definitely cannot break the scale. You cannot 0 and then suddenly jump to 1.0, for example. You cannot 0, 1.0, and then 1.2, 1.4, 1.6. Cannot like that. You cannot jump. The scale must be continuous. You cannot break the scale. Okay. What I mean by break the scale is, I know in mathematics you got learn where you can make the scale shorter. For example, you draw like this. You draw this kind of thing like this. You break the scale. So this is definitely no. In physics, you cannot do this kind of thing. Cannot. Okay, definitely cannot, because it will affect the result. Affect the equation that you are going to construct from the result of the graph. Okay, from the graph, you will make. You are going to make the equation, linear equation. So if you break the scale, it may affect the equation that you make. Okay, so definitely cannot. Alright, so scale must always start from 0. Okay, after you have the scale, you must label the axis. So in this experiment, it is voltage against current. So you use the symbol for voltage V. Must use symbol. Don't write the whole word, voltmeter reading or voltage. Don't write the whole word. You write the symbol only. Okay, symbol for voltage V, and then slash the unit for voltage is volt. So it's also V lah. And then current, use symbol I. Slash the unit for the current, ampere. Okay, must have the symbol for the physical quantity and also the unit must have. Okay, must have. After that you plot lah. Okay, you plot. After plot, then you draw the line. So you see the line that I draw, Don't chase after the point. Don't chase after the point. Don't make sure must touch the point. No, don't think of it like that. Your line, the line must show the line must always show the pattern of the data. That means what is the progress of the data. You see the data is moving in this direction right now. The data is moving in this direction. Okay, moving in this direction. So you draw a line that can show the direction, the progression of the data. Where will the data go? Okay, understand? So the line is basically like the summary of the data like that. Okay, a summary of the data. Okay, so after done, draw the line already. So let's answer the question. So the first question, calculate the gradient of the graph. Okay, so when you want to calculate the gradient of the graph, you must draw a triangle, because when you want to draw, when you want to calculate gradient, you need to choose 2 points on the graph right now. You want to choose 2 points. So let's say the point that I choose is this point, and let's say this point. Okay, let's say I choose these 2 points. Okay, this point. Why I choose these 2 points? Because these 2 points, the line of the graph, it pass through the intersection. You see or not? We choose a point that is where the line pass through the intersection very nicely, so that you can get the coordinate that is very accurate. For example, this one, the coordinate going to be 0, 1.5. Okay, and then this one, the coordinate going to be, this is 0.6, and this will be 1.3. Okay, sorry, 1.0, 1.06. Okay, 1.06. All right. So you choose the 2 point already, and then after that you need to draw a triangle. Okay, you must draw a triangle to join. You draw a triangle to show which is the 2 point that you choose. Okay, and then another one here. Okay, get the idea. So you draw a triangle like this to show that this point and this point is the point that you choose to calculate your gradient. Okay, so now we calculate the gradient. Okay, y2 minus y1 over x2 minus x1. Okay, so based on the coordinate, okay, 1.06 minus 1.5 over 0.6 minus 0. So you get negative 0.733 volt per ampere. You want to write volt per ampere also can, or you want to write the unit for resistance also can, ohm. Okay, you want to write ohm also can, volt per ampere also can. Okay, so one thing that is very important is this. Okay, you see this, when you want to calculate the gradient, when you want to substitute the value inside y2, y1, x2, x1, you must make sure that you substitute it properly. Okay, that means you must write 1.06, this one, this number minus this number, this coordinate minus this coordinate, this coordinate minus this coordinate. You must show what are the 4 coordinates. What is the 4 number here? You must show. Okay, this is very important. You must show. Why you must show? Because the examiner may compare this. Okay, they may want to compare this number with the triangle, with the 2 points that you choose from the triangle. Understand? With these 2 points that you mark in the graph. Okay, this coordinate here and the coordinate of the 2 points that you choose must be the same. Okay, it must be the same. If not the same, then you minus mark lah. Okay, so make sure that you show the coordinate here. Okay, after that, B. Okay, B is the question want you to write a linear equation of the graph and relate to the voltage drop. Okay, so y equals to mx plus c. So y is b, m is the gradient negative 0.733, x is the current. Okay, plus c, y intersect is 1.5. Okay, and then it says relate to the IR equals to EMF minus V, right? So that means you need to rearrange this so that it corresponds with the equation. So this one move over here, negative move over here, become positive, so 0.733 I equals to, so this is 1.5 minus V. Okay, so you see this is comparable to IR equals to E minus V. Okay, after that C, they want you to calculate the resistance, right? So you want to straight away write also can, or you want to show the calculation also can, but I don't think there will be a mark for calculation. So IR equals to 0.733 I. So R will be equal to 0.733 ohm. Okay, so this is the internal resistance. Okay, after that is D. Okay, D, they want you to determine the EMF. So by comparing the equation, this equation with the IR equals to E minus V, you can straight away get that the EMF will be equal to 1.5 volt. Okay, so this symbol is actually symbol for EMF . Okay, alright, so this is the first the few type of question that maybe they will ask. If they ask this kind of question, then this is the way that you answer. Okay, so the next type of question, okay, I try to compile, I try to find okay, what are the kind of questions that they may be going to ask. So this is the kind of question that maybe they are going to ask. So okay, based on the graph, state the changes to the potential difference when current increases. So what is the changes to potential difference? Okay, decrease linearly. Decrease linearly because it's going down in a straight line, right? Going down in a straight line, so decrease linearly. Okay, decrease linearly. Okay, so second, determine the value of the potential difference V when current equals to 0. Show on the graph how you obtain the value of V. So basically, what it want here show on the graph is they want you to show on the graph that the line touch the y-axis, because when it touch the y-axis, then you can see when current is 0, the voltage is how much. So from here you have a line, you just show the line that the graph touch the y-axis, then it will be enough to get 1 mark. And then another mark is you take the reading here, so 1.5. Okay, so 1.5 volt. Okay, you see 2 marks. 1 mark is on the graph, another mark is shown here, 1.5 volt. Okay, after that, name the physical quantity that is represented by the value in A2 here. This one is what? This is electromotive force. Okay, this is electromotive force. Please write the whole word, don't write EMF only. Write the whole word. Okay, electromotive force. Okay, name the instrument that can be used to measure the physical quantity. So what is it that you can use to measure electromotive force? You can use voltmeter lah. Okay, you can use voltmeter. After that, okay, the internal resistance R of a dry cell is given by R equals to negative M, where M is the gradient of the graph. Calculate the value of R. So R equals to negative M, and M is the gradient. So that means you show how you calculate the gradient. So this gradient is 1.06 minus 1.5 over 0.6 minus 0. Okay, and then equal to negative 0.733. So that means is positive 0.733 volt per ampere, or you want to say away write ohm also can. Okay, you see this question have 3 marks. The first mark is actually on the graph. The first mark is this triangle. Okay, when the question asks you to calculate gradient, you must draw a triangle to show which is the 2 point that you choose to calculate your gradient. So the triangle got mark. Okay, triangle 1 mark. This one you show your substitution, another mark, and then the final answer, another mark. Okay. Okay, this one part C. Okay, this question from the graph, take the value of V when I equals to 0.8. So okay, so I want you to change this one 0.8 into 0.4 Okay, 0.40 ampere. Okay, show on the graph how you obtain the value of V. Okay, so you go back to your graph. Okay, when it is 0.4, how much is the value? So that means you need to draw a line. That means you do interpolation. Okay, you do interpolation from 0.4. Then here. This. Okay, draw an arrow. Okay, this line, if actually you should draw a dotted line, dotted line. The triangle actually also dotted line. Okay, dotted line. Triangle also should be dotted line. Okay, all right. So you show this line interpolation. Okay, this interpolation line, then you will get 1 mark. 1 mark for this line that you draw. Then you write the reading how much? 1.2 volt. Okay, when 0.4 ampere is 1.2 volt. Okay, so next, the electromotive force of a dry cell is given by the equation below. E equals to I, R plus R. Calculate R when I equals to 0.8. Okay, so this one change to 0.40 ampere. Okay, so this is the equation that they give. E equals to I, R plus R. Okay, so this E is actually the EMF. Okay, this E is actually the EMF. It should be the symbol for EMF. Okay, all right. Okay, EMF equals to I, R plus R. Okay, so they want you to calculate R when the current is 0.4. So the EMF, we already know that it is 1.5. Okay, the current is 0.4. And then the resistance is how much when the internal resistance is. So here you already got calculate how much is the internal resistance. Okay, this is internal resistance 0.733 ohm. Okay, so you solve this and then you should get R equals to 3.017 ohm lah. Okay, so that means it means that this R, this is the resistance of the resistance of the rheostat when the current is 0.4 ampere. Okay. Okay. Other thing that they may ask is ask you to give the precautionary measure. Precautionary measures. Okay, so what are the precautionary measures that you can give is, the first one is make sure all connecting wire are connected tightly. Okay. Second, you can say make sure the position of I is perpendicular to the scale of ammeter and voltmeter to reduce parallax error. Okay. Okay, another one you can say is never mind. Okay, these two is enough. Okay, these two is enough. Okay, these two is enough. Okay, so that's it for this practical practice. So all the best. All the best.